Okay, let's continue. Geometry. Geometry of addition and multiplication. We can ask, can we visualize addition of positive rational numbers? So consider this example. You have a segment of length m by n and another segment of length r by s. Mn, rs are positive integers. We can ask, what is the total length? So let's say the claim is that the total length is m by n plus r by s. Note that we defined m by n plus r by s so that we had algebraic convenience. We defined m by n plus r by s so that we had a specific kind of algebraic convenience. We had a specific kind of distributivity. So for that we defined addition of rationals in this way. So now we are saying, if we have two segments of length m by n and length r by s, the total length of the segment is m by n plus r by s. We need to show this. The claim is this. So we will show. It suffices to show this relation, that ns times total length equals ns times total length is ms plus sm plus nr. We will show this relation, and this will show that the total length is m by n plus r by s. Okay. To show this, consider ns copies of total length. So you consider ns copies this is of length m by n, this is of length r by s, this is of length m by n, this is of length r by s, and for these we have taken total of ns copies of total length. Now the first parts add to, so if you take only the first parts, what do they add to? They add to So there are ns copies of length m by n. Add 2. So this is of total length. Ns times m by n equals ms. So the first parts, add to sm in length. I'll write sm in length. Okay. Now similarly the second parts. The second parts, or I'll write it here. The second parts, add to. So if you take r by s, so ns copies of r by s, this adds to ns times r by s equals nr. The second parts add to add to nr in length. So if you take ns copies of the total length, we found that the first parts add to sm in length and the second parts add to nr in length. Hence ns times total length equals sm plus nr. Or you can write sum of first parts plus sum of second parts, or we can just ignore it. Ns times total length is sm plus nr as needed. If we take ns copies of total length, the length which we get is sm plus nr, because the first parts add to sm in length and the second parts add to nr in length. Okay, so we showed that the total length is the sum of the fractions m by n plus r by s. Okay, so here we have visualized addition of positive rational numbers. We can ask, can we visualize multiplication of positive rational numbers? So let m by n r by s be rationals where m and r s are positive integers. Now if we begin with length m by n, and first we take take R copies, we get m by n, m by n, and there are R copies, and then the total length will be R times m by n equals Rm by n. So this total length will be Rm by n, R times m by n. Now if we take or if we just want to use addition, we can do that as well. We can write in terms of addition alone, m by n plus m by n so on R copies equals Rm by n, right? Now if we divide into s equal parts, so first we took R copies, second we divide into s equal parts, then we get Rm by Sn Rm by Sn in s copies. This is because if we take Rm by Sn, if you take this s times, we get, if we add this number s times, we get Rm by n, the original length. Hence first we took R copies of length m by n, we got length Rm by n. Now we divided into s equal parts, then we got length Rm by Sn. So each part will be length Rm by Sn. We got s copies of length Rm by Sn. So we have found an interpretation of the product of these two rational numbers. Hence, for a segment of length m by n, adding R copies and dividing the result into s equal parts gives parts of length Rm by Sn. So if we begin with length m by n, add R copies and divide the result into s equal parts, we get parts of length Rm by Sn. So this is one way to interpret the product of two rational numbers, R by S and m by n. Now there's another better way in terms of areas. So consider this example. Consider a thin sheet of liquid. Okay, one thing, I'll use blue for all the questions just to emphasize on the questions. What is the total length? Okay, so consider a thin sheet of liquid in a 1 unit by 1 unit square. So you have a 1 unit by 1 unit square, and in this there is a thin sheet of liquid. You have a thin sheet of liquid of the form 1 unit by 1 unit square. Now consider positive rationals m by n and r by s. So m and r s are positive integers. Consider the rectangle consider this rectangle of side lengths m by n and r by s. Okay. Now we can ask, in this setup we have a thin sheet of liquid in a 1 by 1 square, and now we are considering a rectangle, an m by n by r by s rectangle. We can ask how many multiples of the 1 by 1 liquid should we take to fill the m by n by r by s rectangle. How many multiples of this 1 by 1 square should we take so that we fill the m by n by r by s rectangle? So we'll study this. Firstly, we can divide the m by n by r by s rectangle. So consider the m by n by r by s rectangle, and so we can divide into, so one side we can consider segments of length 1 by n, m copies of length 1 by n, that will be one side of the rectangle, and we can take r copies of the length 1 by s on the other side. Then we get a division in this format. We can divide into little rectangles of length lengths 1 by n and r 1 by s, of sides 1 by n and 1 by s. So first observation, hence the m by n by r by s rectangle is 1 by n by 1 by s rectangles taken mr times, right? So there are mr many of these small rectangles. So each small rectangle has sides 1 by n and 1 by s. So the m by n by r by s rectangle is 1 by n by 1 by s rectangles taken mr times. This is the first observation. We have divided the m by n by r by s rectangle in terms as mr copies of 1 by n by 1 by s rectangles. Okay. Now we can ask to fill 1 by n by 1 by s rectangle by liquid. How many multiples of the 1 by 1 liquid should we take? So we have divided the original rectangle into MR copies of 1 by n by 1 by s rectangles. Now we can ask, to fill one unit, one by n by 1 by s rectangle by liquid, how many multiples of the 1 by 1 liquid should we take? Now we can divide the 1 by 1 square, or should I write? We can divide the m by n by r by s rectangle as like this, and now we can say we can divide the 1 by 1 square as, so you take lengths 1 by n and you take n copies, then the total length will be 1. And for the other side you can take 1 by s and you can take s copies. So this will divide, we can divide the 1 by 1 square as like this, into ns copies of 1 by 1 by 1 by s rectangles. So the second observation is, hence 1 by ns of the liquid in 1 by 1 square. So the question was, what fraction of the liquid, how many multiples of the 1 by 1 liquid should we take to fill 1 by 1 by 1 by s rectangle? From this division above, we can see that 1 by ns of the liquid in 1 by 1 square would fill a 1 by n by 1 by s rectangle. So we have two observations. Firstly, the m by n by r by s rectangle is mr copies of 1 by n by 1 by s rectangles, and each 1 by 1 by 1 by s rectangle can be filled using 1 by ns of the liquid in the 1 by 1 square. From 1 and 2, we see mr times 1 by ns of the liquid. So the full rectangle is mr copies of the 1 by 1 by 1 by s rectangle. So mr times 1 by ns of the liquid in 1 by 1 square would fill the m by n by r by s rectangle. So this is what we found. 1 mr times 1 by ns of the liquid in 1 by 1 square would fill the m by n by r by s rectangle. We say the area of m by n by r by s rectangle is mr by ns unit square. This is what we say. The area of m by n by r by s rectangle is mr by ns unit square. We take mr by ns fraction of the 1 by 1 square 1 by 1 liquid to get the amount of liquid in the m by n by r by s rectangle. So we say this statement as the area of the m by n by r by s rectangle is mr by ns unit square. So this is another interpretation of the product of uh, two rational numbers. So we have the product of m by n and r by s in the amount of liquid. So right, so this is another interpretation of the product of two rational numbers. This is one interpretation of the product of two rational numbers. To interpret m by n times r by s, consider the length m by n, take r copies of the length and divide the result into s equal parts. Then you get parts of length rm by sn. So this is one way to interpret the product. And another way is, if you take an m by n by r by s rectangle, how much amount of the liquid in 1 by 1 square should you take to fill the m by n by r by s rectangle? It turns out you should take mr by ns amount of the liquid, mr by ns multiple of the liquid in the 1 by 1 square to fill the m by n by r by s rectangle. So this is another way to interpret the product of two rational numbers. Okay, so that's all for this part. See you in the next part.